Okay, I am looking to find out how many minutes there are in 2.45 hours. So that's my question. So whenever I do these conversion problems, these are called dimensional analysis problems, I need to kind of write a pathway. What am I starting with and what am I ending with? So I want to find out how many minutes there are. So this is where I want to go. And I'm starting with 2.45 hours. So let me write my map. So I'm going to go from hours. And then, do I know how many minutes there are in 1 hour? Yes. So I have a direct conversion here. So I can go right from hours to minutes. My conversion factor, I know that there is 1 hour and 60 minutes are equivalent statements. 1 hour is equal to 60 minutes, or there are 60 minutes in 1 hour. So this is my conversion factor. Now, conversion factors can be written. You can write it like this, or you can write it like this. These are equivalent to that conversion factor up above. So sometimes I need to use it in this form. Sometimes I need to use it in this form. It depends where I'm headed. So in this problem, I am going from hours to minutes. So I'm going to start with hours. I'm going to multiply it by something in order to get to minutes. So I've kind of filled in, I have to fill in the blanks here now. All right, so I started with 2.45 hours. I'm going to multiply it by something so that the hours will cancel and minutes will be left. So of the two conversion factors I have on the side here, two conversion factors, should I put minutes in the numerator and hours down below, or should I put hours in the numerator and minutes down below? So I gotta look here. I need the hours to cancel out. So they need to be in a different, since it's up top, it needs to be down below so it will cancel out. And then I want minutes on the top because that's why I want my answer in. So I am going to choose this one. So I will put 60 minutes here, and I will put 1 hour on the bottom. And now when I multiply across, the hours will divide out, because when you have units that are in different locations, one's in the numerator, one's in the denominator, those will cancel out. Then I will multiply across the top and across the bottom. There's nothing on the bottom here, I just have 1. So 1 in the denominator does not change the answer. But when I take 2.45 and I multiply it by 60 on my calculator, I get 147 minutes. So there are 147 minutes in 2.45 hours. Let's look at another one. In the next one, it says convert 5.6 miles to feet. So again, when I start these dimensional analysis problems, I want to start by making my map. Can I go directly from miles to feet? Yes, I can, because I have a conversion factor available. So I'm going to start with miles. I'm going to multiply it by something, and then I'm going to get to feet. So this problem says 5.6 miles. Now, again, I have to decide, how should I write my conversion factor? Should I write it like this, or should I write it like this? And so because I want miles to cancel and feet to be left, I'm going to put feet up top and I'm going to put miles below. And I am going to now attach the appropriate number that goes with the mile, 1, and 5,280 goes with feet. So I have chosen this one, feet. Now, next, the miles will divide out when I multiply these together. And I'll be left with 5.6 times 5,280. So there are 29,568 feet in 5.6 miles. So let's take a look at this next problem. This one says, convert 200 meters per minute to meters per second. So on this one, I'm starting with meters per minute, and I want to go to meters per second. So I'm not changing this top one, am I? I'm staying in meters, but I need to change this denominator unit from minutes to seconds. Can I go directly from minutes to seconds? Yes. In 1 minute, there are 60 seconds. So I need to write that out my two different ways. I can either write it like this, or I could write it like this. So I always like to write them off to the side, and then I can see them and I can choose the right one for my problem. So I've got 200 meters per minute, and I'm going to multiply it by something to get my answer, which should be in meters per second. So now this time, I'm not touching the meters. So I have to change the denominator, and I want the denominator unit to be seconds. So which one should I choose here? If I want to get rid of minutes, I'm going to have to put minutes up top. Because when they're in opposite locations, then they will cancel. And I want it to say read seconds on the denominator. So I should choose this one. So I'll put 1 minute here and 60 seconds down below. And now when I multiply, the minutes will cancel and the units will be meters per second. So this time, when I multiply, I'm going to multiply across the top, and I'll get 200. 200 times 1 is 200. Then I'm going to multiply across the bottom. And I don't see anything here, so I can think of this as just a 1, because you can always write a whole number as 200 over 1. Any whole number can be written as the over 1. It doesn't change its value. So 1 times 60 is 60. Now I'm left with 200 over 60 meters per second, which is correct. But I want to make this, I want to reduce the fraction or either write it as a decimal, depending on what the question asks me to do. So 200 divided by 60 is 3.3. It's a run-on decimal. So 3.3 meters per second would be my answer.